Yes. So, firstly, like every time, let's define what is Linux, because we do have to define what we want to see today so we can understand it better. So, Linux is a free and open source operating system in itself. Based on Unix, you might have heard about things like Ubuntu, like Debian, things like that. These are called distributions of Linux. So, key features in our case where we have a big interest is that it's open source, accessible to everyone, and everyone can view how it was made, which is quite a critical part when we study cybersecurity. Stable and secure and efficient. Certain distros more than other, but Linux is known to be very, very stable and efficient, and it's absolutely used everywhere. The university uses it for there is databases, services for everything. So, and not only the universities, hospitals use them. You got space station use it actually. So it's absolutely everywhere. Multi-user multitasking support. So it's made for handling multiple users on the same machine. Widely used for servers, cybersecurity, and development. Like I said before, this is something that is absolutely based everywhere. You will not be able to go on a numerical system and see that they're not running Linux, or maybe they're in love with Windows, which happens. You have some companies that are madly in love with Windows and they will say, we don't use Linux, and they have the problems that come with it. So we have some very, very known distributions, Ubuntu, Debian, that you might have heard of, Fedora, a bit less known, but also very, very popular, Kali Linux, which is the go-to distro for cybersecurity enthusiasts like ourselves. So you probably already heard about it. We do have CentOS, Arch, a lot of things. Arch is considered as being a very, when you install Arch, you basically have absolutely nothing. So it makes it absolutely perfect for customization if you want to customize your distro. But at the same time, if you're brand new, I would not suggest going for Arch straight away, because you will have a lot of work to do to have a proper normal distro. So what is it used for? Because, okay, now that we know what it is, we need to understand what it's used for. In general, so not for our case as cybersecurity enthusiasts, but in general, Linux is used for a lot of things. So servers and web hosting, most of the servers are hosted on Linux. For cybersecurity, it is quite used for penetration testings, forensics, things like that on distros that have the tools already installed, like Kali Linux or Parrot OS. Development, it's preferred. You have a lot of good IDEs that are available on Linux, and it's quite useful for automation as well with services. Cloud computing, you have everything Azure, AWS, everything like that is running with Linux. Embedded IoT device, you can guess it, TVs, everything, they run Linux. And finally, supercomputers. 100% of the supercomputers in the world run Linux. Of the top 500 supercomputers in the world run Linux. That just means that, who wouldn't want to use Linux? That's the real question. So why, in our case, we would use Linux? Mostly because it's open source. So as I said before, you can see exactly what's going on. So that for us, we really, really enjoy that. You have control about almost everything, because you know how it's built, you can control basically everything. You can even make your own distro if you want. Good luck with that, but you can definitely do that if you want. You have strong permission systems as well. You can control everything. Built for networking, customizable and lightweight. As I said, certain distros more than others, but most of the time you can do really what you want with Linux. Very powerful command line, specialized securities distros, like we said before. So a bit of history. I think you all have seen this guy's face already, maybe in history books, maybe in first year, if you were in computer science. If not, he's the GOAT. So Richard Stallman, as he's the quote at the start of this presentation is from him. So he's the founder and the starter of the GNU project, which was made in 1983. But before that, something called Unix systems were developed at Bell Labs by a guy named Ken Thompson and Dennis Ritchie. And it's the foundation of the Linux design. And Unix is absolutely, it was absolutely a revolution at the time it was made. So then came the GNU project, and then the birth of Linux. As we said before, Linux is not something alone. Linux is more nicely called GNU Linux because it's the Linux kernel, but combined with the GNU tools. So to make it simpler, if you didn't have the GNU tools, you wouldn't be able to throw certain commands like ls, like cat, like everything that you would like to use like this. are part of the GNU toolkit. So thanks to this guy, Richard Stallman, absolute legend, we do have everything that we need nowadays to have a proper Linux. So then it was the platform grew, became more popular, and it was adopted for most of the things that we use today. Android phones, everything like that, adopted Linux. Mac as well is a derivative from POSIX systems, but that's something else. So why would we go from Linux, from Windows to Linux, or why would we choose to be more interested in Linux? So as you can probably tell from this graph, I am a Linux enthusiast. I do like Windows as well, but for working purposes, I do prefer Linux. So cost-wise, absolutely free, nothing to pay, unlike the Windows where you have to pay those license keys. Fully accessible, Windows is closed source. Security-wise, you can control absolutely everything. You have visuals on everything, all the processes, absolutely everything. Windows, you have less visuals, you have more control of the Windows environment, and you do have more malware that are... security is more axed against malware repudiation, and Linux is more generally based. Performance-wise, Linux lightweight. Customization-wise, as we said, you can do everything you want with Linux. You want a distro with pink background, you can have that with 2 lines of code, so it's absolutely, you can do whatever you want. Sky is the limit. Command line, powerful in Linux, less central in Windows. You do have PowerShell and CLI, which is... good. I mean, they won't be used for the same thing, but it's less central. Software management, you can do everything with packet managers, and use case everywhere. Linux is everywhere. Wonderful. The usual meme. So this one is, as we said before, is just to prove that Linux is absolutely everywhere. So it is even used in the International Space Station. That proves how reliable and how much trust we have in these operating systems. So now I'm gonna let you guys know something. It's gonna be quite a lot of content. There's gonna be a bit of text. If there is any questions, stop me right away. Like, don't hesitate. Just, what is that? Or I didn't understand. Or what you say is false. It happens sometimes. So go for it. Okay. Damn. Okay. Yeah. Cheers. Thank you. So Linux is structured as a file system. So there are multiple folders where you will have everything that is required for the OS to function. But when I say everything, it's absolutely everything. So you will have a folder called boot. If you get rid of that, you won't boot. So, you have total control, but as well, with great power comes great responsibility. So if you take out the whole boot folder, good luck booting back in your machine for the next round. So in Linux, everything is a file. There's a single root structure, which is like a tree. So you have the slash, which is called the root directory that you can see all the way up there. So this is the top of the tree. Really, from there, you can go in different folders where you will have different things. So the home folder is usually where the users are stored. The bin folder is usually where the binaries are stored, so the tools and everything would be in the bin folder. etc was by the past kind of like a garbage collector, was etc. But now it's more about configurations. Then you go var for variable data, TMP for temporary. I'm not going to list them all, but you get the idea. You go big, the root is at the start, then you go down in the tree and you have access to everything as folders. So it's called a file system. Bit more in depth, these are certain folders that I chose to talk about because I think they can be quite important in cybersecurity. The bin folder, as we said before, is where you have the binaries. So when you call, for example, a command, it will call actually the bin / the name of the command. So it will go get this in the bin folder, which stands for binary. So this is quite important to know that the tools are located here. Boot, as I said before, take out the boot, you won't boot. You have control over everything, but also be careful. etc used to stand for etc. Now it's more everything to configure. You will have most of the configurable files and everything regarding that matter. Home is important. Doesn't look like much right now, but when you arrive on a brand new machine, the first thing you might check is how many folders exist in home. Each folder will be for a user, and that's how you typically and really basically map who has access to this machine and what users exist. You can define a user's home directory to not be in the home folder, which makes it a bit more complicated. But by default, it would be in the home folder. Then you will have the root, which is folder for the super user. the admin, the big guy. So most of the time you won't have access to that, but sometimes you might have cool stuff inside when you have access or you do a privilege escalation. Can be quite useful in competition. Sometimes there are flags hidden in the root folder. TMP. TMP doesn't look as important as well. TMP, temporary. Why the hell would I go in temporary folders? Because sometimes, and most often, it is the only folder where you will have write access on a machine, on a Linux machine in a controlled environment. Because you need to have access to that to drop certain files that you wouldn't care of that will disappear on reboot. This TMP will often be used in competition scenarios to drop your exploits or anything that you need. So take a look at TMP. It's a good place to drop stuff. But apart from that, it's not very useful. So I'm not going to go over that. If you guys want to see the slides later on the website, you'll be able to see. This is actually the whole way it's structured. So yeah, you can see there's a lot of things. But I'm not going to go in depth on that. Then you do have Linux packet managers. So you're going to ask me, okay, I want to download a new app. I want to download new stuff. How should I do it? I don't have an Apple store. I don't have all that. So packet managers. There are a lot. But for the basic one, very known one is apt. So you would just say apt install, and you would add a keyword named sudo before. You say apt install name of a package. So I don't know, apt install ls if you didn't have ls. Or apt install something, which would install it. So you do have other packet managers. On Mac, I think you have Homebrew, which is a very common one. But you can see there's so it's just something that pulls code from a repository somewhere online, and that enables you to download this tool. It's the repository where it pulls from are trusted, and they are you have some default repositories that are defaultly trusted that are installed on your VM on your machine, but you can add more. If you trust and you know the source, you can add a lot more. You will download stuff that you weren't by default allowed to download, but if you don't know what you're downloading, you might catch a bit of a virus or things like that, so just be careful about that. So quickly, what's a process? You might have heard the word process, things like that. So process is something that carries out tasks within the operating system. It's something that is can be for of a computer program in action. It's a dynamic entity. It does a lot of things, constantly changing, and relies on the instructions executed by the processor. Again, I'm not going to go too much in depth. You guys are not here to hear about definitions, things like that. So I'm just going to go quickly. But you need to know there's a concept of a process, which is something being executed. Simple as that. A process has an ID associated with it. It uses system resources, so hardware resources, and you can run it in user mode, kernel modes, and processes have permissions attributed to them. So process can run as admin, which can be good if you can overtake this process to later have more control. So example of process, Firefox SSHD. Remember that to check your active processes on Linux, there's a small command called ps, which would show you exactly what is actively running. Bit more, processes have different states. The process can be running, can be waiting, can be stopped. Running, it's in the title, that means it's just running. Waiting, waiting process can be interruptible and uninterruptible. So a certain process will say, nah man, I'm not shutting down, no way. Even if you want me to shut down, I'm not shutting down. Because they're using hardware resources, and that would actually corrupt the device. Some of them will be much more chill, and they will let you know that, okay, you want to stop me, I'll stop right there. So these are called interruptible processes. Stop processes, they're stop. No, not much more on that. Linux shells. So Linux shells, there's a lot of shells that are available on Linux. You can download whatever you want on Linux. That's the beauty of it. Fully customizable. The common ones and the ones you will mostly get when you do a default install will be SH, so the original Bourne shell. The old Unix shell, now replaced most commonly by Bash, which is Born Again shell. It's as well as a default one. My personal favorite is ZSH, absolute wonder. But I mean, you guys can choose. This one gives you a bit more advanced controls. You will see a bit better graphical interfaces, things like that. Then you have Fish, KSH, and the list is non-exhaustive, so you have a lot of them. Then why would we like a shell? Because you can do absolutely whatever you want with it. As long as you master the syntax, you can do wherever. That's the beauty of Linux. Interpret user commands, manage output inputs. You can define variables, use those variables, everything. It's like a big program, but you're in the program and you can do whatever you want. So, fun fact: if you want to change to ZSH because it's absolutely the best shell, this is the wonderful shell. You just drop that in your terminal, and as long as you do have the binary, if you guys remember, we said that in the bins were the binaries, the ZSH binary, you will be able to change your shell, and you can do it as easy as that. Boom, one shell to the other, perfect. Use ZSH, it's goated. So now a bit. Sorry, there's a lot of text. It's not the best. It just needed to contain a lot of information, and I didn't really know how to structure it. But the most important part you guys need to keep in mind here are the symbols here, and on this line, and their associated functions. So / is the root directory. Dot in Linux is the current directory. So sometimes you might want to say move something that was there to my current directory. You can just do it with dot instead of inputting your directory. Dot is go back. So it means go up one level in the tree. So if I was in /home, if I go in cd ... it will bring me back to the root. So at the beginning. So yeah, dot just gives you lets you go back one step above in the tree. Then you have the wiggly wave. I don't know how you call it in English, but the wiggly wave. This is just something to say that it's your home folder, home directory. Then you have the minus, previous directory, and then the star, which is quite used when you're looking for text files that can say, just to specify, it's a wildcard, so you can put anything before, anything after. So, common commands. I don't know. Everybody here has already used Linux, or do we have people that never use Linux in their life? Okay. So you guys, stop me if it's not clear, and really don't hesitate. Just go for it. So you do have a few commands that are very useful when you're using Linux. So there will be videos and demos just after. PWD. It tells you where you are right now. So it's good to know where you are so you can know where to look. So PWD, print working directory. Sorted. LS, list files, list. LS stands for list. So you will just see so when you type LS, you will see all the contents of where you are right now. If you just type LS, if you type LS and a specific path, you will see the content of this path. You can add options which are annotated with a small minus in front, and then you can add LA, things like that, or a lot of options to enable you to see more or see more specific things. Then CD is used to change directory. So you will be somewhere. Imagine on my Windows computer, I would click on a folder, click on another folder, click on something else. Then in Linux, instead of doing that, I'm doing it all by text. So it's at the start can be a bit confusing, but CD will make you change directory, so change folder. CD somewhere. So for example, I'm in home user right there. Oh, I'm gonna use that actually. So I'm in home user right there, and then I want to go in documents. So I would if when I do PWD I see home user, I would just do CD documents to add documents to my path and go in documents. Then cat is used to display file contents, very useful when you have ASCII text that you want to read. So that's it. So the typical output of ls command, don't worry, there's a lot of things, but so this is on my Linux. So typical use would be, as I said, ls and the location after. You do have arguments that you can add here, and as you can see, if I just put ls alone, so this is a shell, and as I'm using ZSH, and this is just a basic ls command. You would see only the directories, and if I had files, you would see the files as well, but you would see basic contents. Then I add the LA option. L stands for long listing, A stands for show hidden files. So hidden files are considered being files with a dot in front of them. They won't appear when you do a basic ls. So to see everything, the usual command would be ls, the minus LA. So you would see the permissions, and you would see even the hidden files. So that's what I did right here, ls LA, and then you can see all those weird letters here that resume the permissions. So who's the owner and who's the last person to have opened the file, when was the creation date, and the name of the file exactly. So you can see here, they all start by dots, so I wouldn't have been able to see them if I used only the ls command. So the bash, the uname command is quite useful as well in our case. You can see system info. So you will see kernel info. You will see a lot of things that will enable you to find an exploit or a way to, an easier way to break the system if you know exactly what it is. So uname, if you do just uname, basic uname, you will get the name of the machine. So Pentas Kali Stickman for here. If I did only uname A shows you everything. Safe way, you get everything, so at least you know 100% what you want. So I put stars. I put some stars here. When I put stars is the thing I think you should really remember from this slide. So there, as I told you guys, there will be a lot of contents, but for when I put a star, it means that's something I personally consider as very important. So an example output would be what has been here. Again, if you guys want to see more, research on the internet, because this will just be a quick overview. So here, a lot of stars. You will have a lot of comments. Sorry for you guys. There's a lot of stuff to remember, but feel free to just stop me or review the slides later on. This is like a way to remember. If you guys want to keep the slides, you'll see some basic commands. So touch makes a file. mkdir stands for make directory, makes a directory or a folder. rm remove, so we can remove a file. rm -r, with R stands for recursive, means that you will delete your folder and what's inside your folder. And nv is a synonym for move, and so you can move something to a new file. Then cp copy. So you see, there's like, it's not some random 2 letters that they drop here. It's just these letters do make sense, but you need to get familiarized with them so you know what you're looking for. But that's it. And for the rest, so if you want to view a file that you created with touch, for example, you would use cat, as said before. Less will see you a page, would give you a page through file, and head and tail would give you the head of the file and the tail of the file. So the beginning and the end of the file, and you can specify the number of lines that you want. When you have a very big file, it can be quite useful. So, permissions, as we saw before right here, these are called permissions. One starts with a D, so as you can see, the first letter, sometimes there's a D. It means it's a directory. When there's nothing, it most of the time means it's a file. So, yes. So as we can see before, a typical line would look like that. You would have RWX. R stands for read, W stands for write, X stands for execute. Why is there 3 of them every time? Because there's the owners, there's the group, and there's the others. So if the owners and the group are able to read, and the others have, so here, no, let's take that as example. Here, the owner is able to read, the owner is able to write, but is not able to execute, as you can see with the blank spot here. The group is able to read and write as well, but not able to execute, and the others are only able to read. So everyone has read access, but only the owner and the group have write access. So you do have this permission system, which allows the user to control exactly how they want their files and by who they want their files to be read, or written, or executed. But how do you change these permissions? With the chmod command. So this is a cheeky one that you will sometimes forget, and that you will that will be a complicated one to realize that your file is actually not executable until you've changed the permission for this file. So chmod command, usual syntax like this. You can use the numbers, which corresponds to this, to set the permissions. So 7 would be the addition of a 4, of a 2, and of a 1. So when you do 755, it would be the owner is able to read, write, execute, and 55 would stand for the others are able to read and execute, and the groups are able to read and execute as well. And this comes with the name of the file you want to change the permissions for after. There's also one other format when you can say the letter, so U stands for user plus X, so that just means give the users executable permissions. Okay, all good? Perfect? Okay. So, quick recap. Just to show you guys, it can be a bit fast, so I'll put on pause. Whenever there's some stuff that that is new. So right there, what I'm doing is, as I said before, I listed the content of my directory, current directory here, and you can see with the wiggly wave, it's my home directory. Then I went into my documents, so you can see it was added to my path. I went to when I did my documents, then I looked again what was in my documents folder, and I can see all my folders in documents. Oh shit, sorry about that. My bad. So then I make a new directory that I call Cybersecurity Society, and as you can see here, it has been added to my folders in documents. So when you make something, it is in your directory, except if you specify it to be otherwise. Then you can see here the permissions automatically created for my folder were so you can see D for directory were read, write, execute for everyone, and the others don't have the write permissions, but they have the read and execute permissions. Again, sorry about that. Okay, so this is just an example of what you would typically do when you create a folder. Then if you wanted to change these permissions, you would use chmod command just seen before. So now I go in Cybersecurity Society, the folder that I just created before, so you can see it's been added to my path. I use pwd to check my current path to see that I'm really where I'm thinking I am. Then I create a file using touch that I call test file. Now when I use ls in my brand new folder, I see the file has been added. Then the command file is used to check what a file is, so what type it is or what content it has. So I look at file, it tells me it's empty. Then I open it and I write text in my file. So once this is done, I save it. So I use nano to write it. And now if I file my test file, I can see it's been updated and it now has ASCII text inside. It's a bit fast, sorry about that. But so after, if I want to read my file, I would use the cat command, and this would copy exactly what was in the file to my terminal so I can see it. So here I check the permissions and everything that is in my folder with using the arguments LA. And you can see my file does not have the same permissions as my initial folder. Then I remove with rm my file. I go back using the ... So you can see my path was came back one node in the tree. And then I remove my And then I remove my my folder using rm -r to do it recursively. So the sudo command is something that is absolutely key in Linux. If you want to do anything requiring privileges, so if you want to delete a user or if you do anything that is considered a bit risky, you need to have privileges. Sudo is the privilege. Sudo stands for super user, and it gives you the root privileges for specific things. You do have a root account. If you have the root account, you can do absolutely anything without using sudo. But to limit the use of the root account and the access of the root account, because it can be dangerous to give this access to everyone, you use sudo. So prompts the passwords for sponsor your password. So as my account here, I would have to enter my own password, not the root password, to use sudo. And then this sudo logs all actions. So then if there's any breach using sudo, you can go back and see what we use. So you need prevents the need of logging at root, and it helps enforce the least privilege, something that we saw in first week, which is quite good in cybersecurity as a framework to secure your items. Why would you use sudo? To install something with a packet manager like apt. So as I said before, sudo apt. Or you want to copy a file, then and the file has restricted privileges, then you sudo to copy it in etc, which is something with limited. You wouldn't be able to copy in that without privileges. Or if you want to launch a service, sudo as well. So you can do it. There are as well arguments with sudo that you can use. No, I'm going to skip that. Something that is very useful in Linux and that we as well like to exploit, or something that can be an end goal, is the password and the shadow file. So this password file is called password, but actually does not have the password, which doesn't make a lot of sense. But this is where you would see mostly where the users of this machine are. So how many users exist, since when they exist, what are their full names, what shell they use, things like that. So a typical entry in the password file would look like this. So the password file which stores the user, and the file that stores the passwords is called shadow. A bit confusing, sorry about that. But so the file called passwd has the user accounts, and the file called shadow has the passwords. But the passwords, not in clear text, because we are secure people. So the passwords, so this file is only accessible by root or by someone with super user privileges. And a typical entry would look like that. And here, between these dollars, you would have what you call the hash of the password. So it's something that the password has been hashed using a cryptographic function for it not to be readable. And the first thing you would see between these dollars is the sign of the hash function. So you would have $6, dollar something else, and that would mean that it's a different hash algorithm that has been used to hash the password. So these two files are key, and sometimes when you look for a user, you might see a weak hash or a weak hashing algorithm that you can crack later on to get the password. Quite useful. So another quick recap about account management. So here, so I go back to my root directory, I look where I am, and it does tell me I am in my root directory, which is perfect. So now I want to move up one step and go in my home. In my home, I see my user folder for my user, which is called Enigma. And then I want to go in Enigma, and you can see now I do have the wiggly wave instead of home, which means I'm in my home folder. So then I want to add a user. So I'm going to use the command called user add to add a user, which we will call tester in this case. So it tells me, well, I'm not able to do it. Why? Because I need super user privileges to be able to add a user to a machine. Then it's because I already inputted sudo a bit before started this video, it doesn't prompt me for my password, but it would normally prompt you for your password. Then you can check exactly the UID of the user with the command ID and with the name of the user after. And I can set a password for my new user. But for that, I also need the super user privileges. So anything that is quite risky or that can affect the machine, you will always need super user or root privileges. So I did set my new password here, and I am going to change to my new user that I created using the command su. Su means switch user, and this enables me to go in this user, and as you can see, ugly terminal doesn't use SSH. So we don't like that. But as you can see, the new user, I am logged in as tester, and I am now gonna check out the environment variables to see what shell this user is actually using. So I'm not asking you guys to remember that, but it's just, I am gonna check what he is using, and what do I see? He's using sh, which, as we said before, is the early version of the shell, the archaeologic shell, the long time shell, which is not very nice, as you can see. Then I use UMI to see who I am. The same ID command to see that I am now tester. And what groups is tester in? Only the tester groups. And I use sudo L to list my privileges. And it tells me what the user may not use sudo because I didn't configure this user to be able to use super user privileges. So now I'm going to switch back to my initial account using the same thing, su. Then I enter my password. And then boom, I'm back. Nice terminal, ZSH. And then I can check who I am. Now I am now back to Enigma, and then I can I can check my shell again, where you see wonderful ZSH with colors as well. So this is just a way you can create user accounts, and after check what the permissions they have, check what shell they're using, check what groups they're part of, because these groups do affect administrative privileges. As you can see here, in the groups, I am in the sudo group. And this enables me to have access to sudo. And when I do sudo L, that was previously not allowed, well then, I can see Sorry about that. So when I do that, please, yes, I can see that this account, Enigma, has all the privileges for super user account, because it's my account, so I give me and myself all the privileges. And then I will just check out the files that we talked about before, and you can see that the user I just created has been added to this file. So you will see a lot of things in that, which are the accounts created by the machine to handle a lot of things. But as you can see, my user created was here. And now I'm going to see if I can check out the shadow file. And I'm not going to show you guys the shadow file, because you guys would have seen the hash and you could have cracked it later on. So the shadow file would have displayed something like that, as we said before, with my user account Enigma and the hash of my user account. So should we resume next time? Because there's a lot of this is a lot of content. Should we resume next time, or do you guys want me to speed through the end of this lecture and keep it as a quick overview, or would I take more time to explain it a bit more in depth next time? A bit more in depth next time. Next time. Next time? Okay. So yeah, I'll leave you guys on that. For next time, what we're gonna see is how you do networking with Bash. The curl command that we did use in a workshop a few weeks ago. So yeah, a few examples on that and a few exercises, and I will add some more content on Linux for next week. Do you guys have any questions? Could I be clear on some things? Do you guys want to see the certain videos again to understand? Can I give you a bit more insight on specific commands? Because I know these kind of slides are a bit painful, because there is a lot of commands just to see. It looks like definitions every time. So you guys don't have to remember it. Yes.
When you ran the ls-a command, it showed the super user, the group, and the current user's permissions. With the group, which group was that?
That is the group that I should be in. So let me just pop back the video. Actually, should be able to see that. Yes. So the group normally should be here. So this corresponds to the group. So what I see here is Enigma is part of the group Enigma. But you would have, if you were a student, for example, and you were in a group of users, for example, you might have that in your courseworks. You would be in a group called mathematics if you're part of the group of students with mathematics. And the permissions for the group would be the second ones. So you might have absolutely no permissions here, absolutely no permissions here, and just a read permission for the last ones. That means that the user that created this file doesn't have access. The group that this file is part of doesn't have access, and the only people that can read the file are people that are not related to the file in any way, so not part of the groups or not the user that created it. You can make these kind of permissions, and that would be just the or at the end right there with lines everywhere here. So yeah, that's mostly it. You just what you really need to remember for today is the permissions, how they work, that you can change the permissions for files, and that you can manipulate file in any ways that you want. Linux is really fully customizable, so you can really do what you want. A bit more on that next time, because I see you guys are a bit tired, so go for it. Cheers, thank you very much.